So in this video we'll be discussing about proving the circle theorem 2, the second one, which is angle subtended at the center is twice angle subtended at the circumference. You would have learned about just one diagram, but here we'll be using two different diagrams. The second one also might come, so you need to know about both. Alright, so the diagrams are, first one is this one. You would have learned this already. Alright, but there is another diagram also that can be drawn, this one. Now in both the cases, if you see, angle BAC is the angle at the circumference, angle BOC is the angle at the center, and what we need to prove is angle BOC is twice the angle BAC. So let's consider the first diagram first. Alright, so the property that we are going to use over here to prove is the exterior angle property of a triangle, which says exterior angle is sum of the opposite interior angles. So we need to form triangles in such a way that each triangle is formed using the radius of the circle, so that we can get on an isosceles triangle. So let's consider the first diagram first. So if you see in triangle AOB, angle BOD is same as angle ABO plus angle BAO, which is 2x. Similarly, in triangle angle COD, if you consider in triangle AOC, then angle COD is 2y. So angle BOC is 2x plus 2y and angle BAC is x plus y. That we can see from the diagram. So we can say angle BOC is twice the angle BAC. Now the second diagram. In the second diagram, same in triangle ABO, angle BOD would be 2y, cos angle OAB and angle OBA both are y each. Similarly, angle COD, if you see, that's the exterior angle for triangle AOC. You can see it from the diagram. That's why angle COD is 2x. Now from this we can say angle BOC is 2y minus 2x and angle BAC is y minus x. That can be seen from the diagram. If you look at the diagram, see this is one part that you need to know. Angle BOC, if you mark, then that's 2y minus 2x. Angle BAC, if you mark, then that's y minus x. And from this we can conclude that angle BOC is twice the angle BAC. So in both the diagrams it could be proved that angle at the center is twice the angle at the circumference. So that's the final statement. Alright. Now one thing you need to know that you got to consider the opposite angle at the circumference. Meaning of that is, if you have a circle and if the angle is formed at the center like this, and if the angle you need to consider at the circumference, then this is the angle opposite to this. You cannot consider this. If you are considering this will be incorrect. But yes, if you are considering this angle opposite to that, if you are want to consider this angle, you can consider. That's the main thing you got to keep in your mind. Whenever you are considering an angle at the center, then you got to consider the angle at the circumference should be on the opposite side. That's the whole proof. Alright? Yeah, thank you.